So today I'd like to show you how we can visualize the EDS data that can be simultaneously collected with EBSD mapping data. So to show this, I have a nitrided steel data set. And so if you're familiar with EBSD, you know it's pretty easy that we get, IPF orientation maps, or we get, EBSD pattern quality maps to kind of show the microstructure. And I'm highlighting these from our Quick Gen toolbar, but the one that I want to show you today is this one here that generates our EDS Quick Maps. These are going to show the different elemental maps derived from the elements of interest. So it's going to generate a list here. You can see these are all listed as auto, and I'll come back to how we can adjust these. And it creates these images, and then for visualization, what it's showing here is each element of interest. It will give a count map, minimum max of counts, and a color assigned to it. And so to show it a little bit more easily, I'm going to use our toolbar here to tile these a little more. And we see all the different EDS maps. And this is a nitrided steel sample, so one of the things I'm going to be interested in is the nitrogen map. So I can make that a little bit larger, and we can see the detail that goes on here. We can see that there's a variation in nitrogen content across it. If we wanted to get an idea of the scale of this, we can go to our interactive toolbar here. We have this map profile vector tool. I can come in and let's draw a line kind of going top to bottom here. Click that, and I'm not usually this tool is used for misorientations. I'm not interested in that right now. I just want to show the map values, and in this case I want to do the color EDS. I'm just going to do the average value in the first range. We'll hit OK, and you can kind of see how that gradient kicks in across that structure. If we wanted to make that, if we go back to our original map, I'm going to minimize this, and we look at our map here. It's doing just a single width of that line. I can go to our settings and adjust that. Maybe I want that to be, maybe 5 pixels wide. And I will erase it, and I can just kind of redraw that. So now when it does this, it's going to do a little bit wider sampling across that and shows that distribution. So we can kind of spatially average out that information. Again, if I only wanted to look at a few different maps, I can close that here. It comes back to my tile. All these maps are the ones that were automatically generated during the process. If I wanted to adjust the coloring of a map, I can bring my nitrogen here. I can right click on the map itself, and it will bring me up the options here for the properties. So you can see here we have our color coded EDS. I can edit this. We've selected the element of interest. We have our minimum, maximum, our average. I can adjust that, and I can specify what kind of color gradient I want. So in this case it's a single color, but perhaps I'd want to do a rainbow gradient, and that might highlight some of the changes across that elemental range a little bit more easily. The other option we have when looking at the simultaneous mapping data is we can create a new map, and I'll do it without image quality first, and I can do what we call our EDS blended color. And in that case, it's an RGB map, or a red, green, blue map, where I can come select some elements. So let's say for the red element, I'll go for iron. For the green, we're interested in nitrogen. And the blue, I know we have some manganese silicides in there, so that might be a good one to pick. We create that map. Now it creates a color where the 3 different elements are used to kind of show things. So we can see some of the gradients present along the surface of that structure. And then if we want, we can go ahead and also start combining it. So I can combine it with, say, our image quality map. And we can see how that structure and colors combine with that. Or I could do something as easy as saying, let's copy and paste that. And I'm going to change this, and let's do maybe our Prius map just for fun to see how that would look. And you can kind of see the variation in the different structures, how we can combine the contrasts from our EBSD mapping along with the EDS information. So it allows us to use both data streams, EDS and EBSD, together to visualize the microstructure. And in a future video, I'll show how we can use this information for improved phase differentiation.